Dati crude, hot, oh, I look good, wow, oh, улыбнись на фото, нету big boy, чё там дati.
Good day everyone, and welcome to our next lesson in this video. I will be discussing about chemical thermodynamics. So this will be a two-part lecture. For this part, we will be focusing with the basics of chemical thermodynamics, and we will be laying down some important principles, and we will be discussing calorimetry as well. So let's begin. Our perception and understanding of energy will be very important in our study of thermochemistry, because this entire topic revolves around the transfer and transformation of energy. Let's first define what energy is. We define energy as a physical quantity that has the capacity to do work, or that has the capacity to hit an object. Energy can also define as a quantity that can be transferred and transformed while being conserved in the process. Ang energy daw kuno may daya kuno physical nga damo ngan may da kuno hiya kakayahan nga magpagana ngan may kakayahan hiya magpaso ba o usang nga bagay ngan also kaya niya mag-transfer ngan mamold daw kuno or mag-transfer kuno while diriya nga while nagamit yang guti nga enerhiya in pagproseso. So ko niton energy is the capacity to supply heat and do work, parang ganun. By this point, we know quite a bit about energy. Energy manifests physically around us every day. Ini kuno nga punto, may aram kuno kita nga gutila about an energy. Ini nga energy manifests physically ha aton daily life or in aton nga bubuhat. And it is observable such as the heat. Ini kuno observable kuno naton nga nabubuhat or something kung nakakapansin ba kuno kuna. An example is the heat or an pason nga tika nga adlaw. That is called the radiant energy being transferred. And energy also manifests itself during combustion reaction. So when you are burning something, and you can also observe when kono an energy let kono itself during combustion pag nasusunog kono may ada kono reaction na nangyayari. So example kono kung may ginsusunong kita nga bagay, may ada kuno energy nga nahihimo. In action, when you are using your gadgets, your phones, and your laptops, etc., those applications all fit the definition of energy. How they exist in different forms, or some common forms that we are encountering include thermal energy in the form of heat. We have work. We can also have potential energy. However, they exist in different forms. Some common forms that we are encountering include thermal energy in the form of heat. We have work. We can also have potential energy, kinetic energy, electrical energy, and so on and so forth. For a discussion of chemical thermodynamics, we will mostly be dealing with chemical potential energy and heat. That is what in the picture is. This example here is the tweezers. We have a little pellet of sugar or sucrose. And the example in the picture is the heated test tube. We have some potassium chlorates. The potassium chlorate is a very strong oxidizing agent. And what it does, has the capacity to release the stored energy of some compounds. So when we drop a pellet of sugar on the heated potassium chlorate, what happens is that the sucrose gets oxidizing, and it's the oxidation release a lot of energy. So this is a visible release of chemical potential energy. Let's talk about the units of energy. So what units can we use in order for us to quantify the amount of energy being transferred or transferred? We're using joules for the SI system. In the English system of units, we are using BTU or British Thermal Units, and we can also use the unit of calorie. Now we can use kilocalorie, kilojoules, megajoules, etc. So you can use prefix in order to reflect the magnitude of the energy. Now, we speaking about the transformation of energy. Our previous example is a prime illustration of the transformation of energy. Against it is from chemical potential energy to thermal energy. However, in the natural world, the transformation of energy is not just limited to one type. In fact, there are countless examples that we can name that demonstrate transformation of energy. So, say for example for falling objects, that is transformation from the potential energy to kinetic energy. And we have two main types of energy, the potential energy and the kinetic energy. In kinetic energy, for power generating turbines, we have the transformation from mechanical energy. Now, let's define the first law of the thermodynamics. This is the most important principle that will guide us into our entire study of chemical thermodynamics. So, what is the state of the first law of thermodynamics? It's very easy statement. It's just state that energy cannot be created or destroyed. It can only be transformed from one form to another. Masayo la kuno ang statement law of thermodynamics. Dire kuno hiya dire kuno kaya hiya himuon or robum ba kuno, but it only kun pwede lugod kuno hiya ma-transform usa to iba na mga bagay. And it's totally conserved. Totally conserved meaning the total energy input should be equal. And meaning ko nohan totally conserved, kailangan ko na and total energy input equal ko na hiya the total energy output, so you cannot destroy energy and you cannot create out of the blue. And the total energy output, so diri mo ko no hiya maruruba ngan diri mo ko no hiya may himo. You can only convert energy from one of its forms to another one of its many forms, and with all of those changes, energy is always conserved. So do not forget the first law of thermodynamics. Yan ko no magagamit ako no ang first law on thermodynamics niyan calorimetry in order as for to draw up the mathematical relationship between the heats that are being absorbed and being released. Thank you.
Okay, as we go on to our topic, now we will present to my slide. The energy change in a chemical reaction is due to the difference in the amount of stored chemical energy between the products and the reactants. The stored chemical energy or heat content of the system is known as enthalpy. So yon. Energy changes and enthalpy changes in chemical reaction. The enthalpy change of a reaction is roughly equivalent to the amount of energy lost or gained during the reaction. A reaction is favored if the enthalpy of the system decreases over the reaction. What is the enthalpy change for the chemical reaction? Okay, an enthalpy change for the reaction is that accompanies a chemical reaction is referred to as enthalpy of reaction as is and is abbreviated delta H underscore Rxn. The value of this depends on how the balance equation for the reaction is written and typically given in units of kJ-mol-Rxn. How is the change in enthalpy related to chemical potential energy? The enthalpy change is defined as the change in heat energy at constant pressure. Hence, in a reaction in which chemical energy turns into heat energy, is the extra heat energy is due to a decrease in the chemical energy. Damon energy, no. Ambot ka nakuha niyo. Okay, what is an example of energy change in a chemical reaction? A fire burning is one of the most noticeable example of a chemical reaction that produces a lot of energy, no? Okay, di ba nakakapasok po? All chemical reaction involve energy change. In some reaction, we are able to observe this energy change as either an increase or decrease in the overall energy of the system. The difference, okay, the difference between energy change and enthalpy change. Anong pinagkaiba? Energy is only measured in joules. Joules, ha? But enthalpy is measured in both joules and joule per mole. Per mole. Enthalpy is also a form of energy. Energy is a state of a matter, but enthalpy is always the energy change between two states. Okay. An example of enthalpy change is, enthalpy change include enthalpy of combustion, enthalpy of confusion, enthalpy of vaporization, and the standard enthalpy of formation. These are the type of energy or what type of energy is enthalpy. Enthalpy is an energy-like property or state function. It has dimension of energy and is thus measured in units of joules or ERGs. Nagets? And its value is determined entirely by the temperature, pressure, and composition of the system and not by its history. Okay. What are the causes or what are causes change in enthalpy? The state of reactant and products like solid, liquid, or gas influences the enthalpy value for a system. The direction of the reaction affect the enthalpy value. A reaction that takes place in the opposite direction has the same numerical enthalpy value but the opposite sign. Sila ito nga tanan ng akon? Oo. Now, ma-proceed kita kan JEMLY APACIBLY. Okay, thank you for listening. I hope you learned something from me, even though I reported in fast and furious way. Charot! Okay, we'll go na. Bye.
Calorimetry is the process of measuring the amount of heat released or absorbed during a chemical reaction. By knowing the change in heat, it can be determined whether or not a reaction is exodermic release heat or endodermic absorbed heat. What is the concept of calorimetry? Calorimetry is the field of science that deals with the measurement of the state of a body with respect to the thermal aspect is in order to examine its physical and chemical change. The change could be physical such as melting, evaporation, or it could also be chemical such as burning, acid-base, neutralization, and etc. Why is it called calorimetry? Calorimetry history. Anthony Lavoisier coined the term calorimeter in 1780 to describe the apparatus he used to measure heat from guinea pig respiration used to melt snow. What is calorimetry importance? Because calorimetry is used to measure the heat of a reaction. It is a critical part of thermodynamics. In order to measure the heat of a reaction, the reaction must be isolated so that no heat is lost to the environment. This is achieved by use of a calorimeter, which insulates the reaction to better contain heat. What is the most important part of calorimetry? Calories are calculated by the change in temperature of the water in the inner compartment, so heat cannot be lost to the canister or the environment. Therefore, the insulation or insulating factors would be the most important part of a calorimeter. What was the main purpose of the calorimeter in the experiment? The calorimeter measures the mass of the liquid along with the temperature change. To determine the amount of energy change, it is different from a thermal analysis. In the thermal analyzers measures properties of a material at various temperatures. What are examples of uses of calorimetry? Calorimeter is a device used for calorimetry or measuring heat capacity or the heat of physical change or chemical reactions. In pharmaceuticals, they are used in drug design, in the chemical industry. They are used for quality control and in biological studies. They are used for metabolic rate examination.
That it good, hot, whoa, oh, I look good.